Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. In this video, let us see about network topology and its types. A physical topology refers to the way in which a network is laid out physically. One or more devices connected to a link and two or more links forms a topology. The topology of a network is a geometric representation of the relationship of all the links and linking devices to one another. The linking devices are also called as nodes. There are four different topologies available, which is mesh, star, tree, and bus and ring. One more thing, hybrid topology is there, which is a combination of all these topologies. Next, we'll see about the mesh topology. In a mesh topology, every device has a dedicated point-to-point link to every other device. The term dedicated means that the link carries the traffic only between the two devices it connects. As shown in the figure here, each and every device is connected to all the other devices. Say A is connected to B, C, D and E. Similarly, B is connected to A, E, D and C. So each and every device is connected to all the other devices using a link. To find the number of physical links in a fully connected mesh network with n nodes, considering that each node must be connected to every other node. That is, node 1 must be connected to n-1 nodes, node 2 must be connected to n-1 nodes, and finally node n must be connected to n-1 nodes. We need n into n-1 physical links. If each physical link allows communication in both the directions, which is known as duplex mode, we can divide the number of links by 2. In a mesh topology, we need n into n-1 by 2 duplex mode links. To accommodate that many links, every device on the network must have n-1 input-output ports to be connected to the other n-1 stations. There are few advantages and disadvantages in mesh topology. First, we'll see the advantages. Since there are dedicated links, it is very secure and privacy is very good, and it is very robust and easy to identify the fault. Disadvantages are each and every device is connected to every other device, so there is a lot of cabling and lot of input output ports are required, and it is difficult to move the network from one place to another. Next one is the star topology. See, in a star topology, each and every device is connected to a central hub. So that's a dedicated point-to-point link only to the central controller, usually which is known as a hub. So each and every device is not directly connected to one another. The controller acts as an exchange. If one device wants to send data to another, it sends the data to the controller, which then relays the data to the other connected device. A star topology is less expensive than a mesh topology. Each device needs only one link and one I/O port to connect it to any number of others. This factor also makes it easy to install and reconfigure. Far less cabling needs to be housed, and additions, moves and deletions involve only one connection between that device and the hub. Advantages of star topology are only one input-output port is needed per device, and so there is less cabling when compared to mesh topology, and it's very easy to install, and fault identification is also very easy. The disadvantages are if the hub fails, then the entire network goes down. Still, here more cabling is required, but less than the mesh topology. Next one is the bus topology. So here it is a multi-point connection. So one long cable acts as a backbone to link all the devices in a network. So as shown in the figure, the nodes are connected to the bus cable by drop lines and taps. A drop line is a connection running between the device and the main cable. A tap is a connector that either splices into the main cable or punctures the sheeting of the cable to create a contact with the metallic core. As the signal travels along the backbone, some of its energy is transformed into heat. Therefore, it becomes weaker and weaker as it travels farther and farther. For this reason, there is a limit on the number of taps a bus can support and on the distance between those taps. The advantages of bus topology are little cabling and it's easy to install, and the disadvantages, it is difficult to modify and fault identification is very difficult here when compared to mesh and star topology. Once the bus cable is broken down, then the entire transmission stops here. The next topology is the ring topology. So each device has a dedicated point-to-point connection with only the two devices on either side of it as shown in the figure. A signal is passed along the ring in one direction from device to device until it reaches the destination. Each device in the ring incorporates a repeater. When a device receives a signal intended for another device, its repeater regenerates the bits and passes them along the ring. A ring is relatively easy to install and reconfigure. Each device is linked to only its immediate neighbors, either physically or logically. To add or delete a device requires changing only two connections. The only constraints are media and traffic considerations, which includes the maximum ring length and the number of devices. The advantages of ring topology are it's easy to install and fault identification is easy because only it is connected to two of the devices on either side of it. The disadvantages are for a large ring the delay will be very high since each and every device has to pass the information to the next immediate device until it reaches the destination only in one direction. If there is any break in the ring, then the entire transmission will stop. Hope you understood the different types of topologies and its advantages and disadvantages. Let us take up some assessment questions. Which network topology requires a central controller or hub? Yes, the answer is star topology. Dash topology requires a multi-point connection. Yes, the answer is bus topology. Thank you for watching this video.